Data gathered informs NASA's Artemis program, helping define the Apollo program, which ran from 1961 to 1970. India's Chandrayaan-2 mission photograph evidence from the historic Apollo-era lunar landings. We're diving deep into the claims and the facts. The moon has always held secrets, and recent space missions continue to pique public interest about past exploration. Let's explore this fascinating cross-mission claim. India's Chandrayaan-2, launched in 2019, was a significant lunar exploration mission, primarily aimed at studying the moon's surface composition, topography, and search for water ice. A claim recently emerged suggesting that Chandrayaan-2's orbiter captured images of remnants from the Apollo missions, raising many eyebrows in the scientific community. The core assertion is that the high-resolution camera on Chandrayaan-2 photographed landing sites or abandoned hardware left behind by NASA's Apollo missions decades ago. This photographic evidence would theoretically confirm the presence of Apollo-era artifacts, such as the lunar lander's descent stages or rovers, still sitting on the lunar surface. The Apollo program, which ran from 1961 to 1972, resulted in 6 successful human landings. Any potential evidence would relate to the landers and scientific equipment left at these specific landing sites. To assess the validity of this claim, we must look at 2 key factors: the capability of Chandrayaan-2's instruments and the publicly available imagery. Chandrayaan-2 carried the Orbiter High-Resolution Camera, or OHRC, which is one of the most advanced cameras of its kind, capable of taking images with resolutions as fine as 0.25 meters per pixel. A thorough examination of the publicly released images from the OHRC has been conducted by independent researchers and space enthusiasts alike, looking for any anomalous signs near known Apollo sites. So what did the experts conclude? Did the Indian orbiter truly spot relics from the 1960s and 70s? The reality is that while Chandrayaan-2 has captured breathtaking high-resolution images of the moon, neither ISRO nor NASA has officially confirmed that the orbiter directly imaged any Apollo-era hardware. The confusion likely stems from the high resolution of the images, which can capture geological features that, under certain lighting conditions, might be mistaken for artificial structures or shadows near the landing zones. In summary, while Chandrayaan-2's technology is world-class, the definitive, publicly verified photographic evidence of Apollo remnants by this mission remains unconfirmed. The current consensus is no, not definitively. While the high-resolution imagery covers some landing areas, no clear, undeniable proof of Apollo artifacts has been presented from Chandrayaan-2's data. The ongoing work of lunar orbiters, including Chandrayaan-2, is vital for scientific study and for cataloging human heritage sites on the moon, paving the way for future missions. The moon has always been a beacon of human exploration. Today, modern missions are taking a journey back in time, revisiting the iconic landing sites of the past. We are entering a new era of lunar exploration, building upon the foundations laid by the Apollo program decades ago. The historic Apollo landing sites hold immense significance, marking where humanity first left its bootprints on another celestial body. Modern missions are returning to these locations not just for nostalgia, but for critical scientific and engineering purposes. New technologies allow us to study these historic sites with unprecedented detail and precision. Modern spacecraft use high-resolution imaging to map and survey the lunar landscape around the old landing zones, revealing details previously unseen. Key instruments are being deployed, including advanced spectrometers and radar, to analyze the composition and structure of the soil. One of the most fascinating aspects is confirming the physical evidence left behind by the Apollo astronauts. New missions help locate and document remaining hardware, such as the descent stages of the lunar modules, rovers, and even the astronauts' tracks. Scientists are analyzing the patterns of disturbance in the lunar soil caused by the initial landings, providing clues about the mechanical properties of the regolith. Beyond history, these revisits are driven by core scientific objectives essential for future exploration. One key goal is studying how historic materials have fared in the extreme lunar environment over 5 decades, informing material selection for future bases. By comparing the original data from Apollo missions with modern high-precision measurements, we gain a better understanding of lunar processes. The findings from these revisit missions have significant implications for the future of human spaceflight. Documenting these sites also contributes to the critical effort of preserving them as historical and cultural heritage for future generations. Data gathered informs NASA's Artemis program, helping define landing procedures, hardware design, and scientific priorities for returning humans to the moon. The revisits to the Apollo landing sites are powerful examples of how the past informs the future. By studying these historic spots, modern missions are weaving a continuous narrative of human space exploration, bridging the achievements of the past with the ambitious goals of tomorrow. Welcome! We're diving into the facts behind the viral claims comparing India's Chandrayaan-2 and NASA's iconic Apollo 11 mission. Let's debunk some common myths. These two missions, separated by 50 years, represent monumental achievements. However, direct comparisons often overlook critical technological and historical contexts. It's easy to look at mission costs or components and jump to conclusions, but understanding the specific goals and constraints of each era is key to a fair assessment. We'll start with a brief overview of both Chandrayaan-2 and Apollo 11 to establish what each mission was designed to achieve. Chandrayaan-2, launched by ISRO in 2019, was India's ambitious second lunar exploration mission designed for complex scientific research. This mission included an orbiter, the Vikram lander, and the Pragyan rover, each with specific roles for studying the moon from orbit and on the surface. Chandrayaan-2 focused on detailed lunar surface mapping, mineralogy, and critically, mapping the location and abundance of water ice, particularly around the lunar South Pole. Now, let's look back at Apollo 11. Launched in 1969, it was the culmination of the U.S. effort to win the space race and achieve the seemingly impossible. Apollo 11 achieved the monumental feat of landing the first humans, Neil Armstrong and Buzz Aldrin, on the moon. The mission's initial goals were demonstrating the capability for a crewed lunar landing and safe return, alongside collecting lunar rock and soil samples. The biggest mistake in comparing the missions is ignoring the half-century technological and manufacturing gap between 1969 and 2019. Apollo 11 required immense power and propulsion technology that was cutting edge for the 60s. Chandrayaan-2 benefited from modern, miniaturized, and highly efficient systems. Claims about cost often fail to account for inflation, the Cold War space race context of Apollo 11, and the fundamental differences in technology required for a crewed mission versus an uncrewed one. The chosen landing sites for both missions highlight completely different scientific objectives and mission risk levels. Apollo 11 landed in Mare Tranquillitatis, a relatively flat, known area. Chandrayaan-2 targeted the challenging, unexplored lunar South Pole, crucial for water ice research. While Apollo brought back physical samples, Chandrayaan-2's orbiter has delivered extensive remote sensing data focused on the moon's composition and potential resources for future missions. To wrap up, let's reflect on the true value of these missions beyond comparison. Apollo 11 solidified America's place in space history, and Chandrayaan-2 solidified India's rise as a modern space power with unique contributions to lunar science. Ultimately, both Chandrayaan-2 and Apollo 11 must be appreciated for what they were: incredible, era-defining missions with distinct, challenging goals that pushed the boundaries of human engineering and exploration. Did India's Chandrayaan-2 mission capture evidence related to the historic Apollo 11 moon landing? We're diving into the real story. The Apollo 11 mission remains one of humanity's greatest achievements, yet persistent questions about its authenticity pop up frequently. Today, we address claims involving a modern mission. We aim to set the record straight regarding these claims, examining the capabilities of Chandrayaan-2 and the verifiable evidence of the Apollo 11 site. Chandrayaan-2 was India's second lunar exploration mission, comprising an orbiter, a lander, and a rover. The orbiter continues to provide valuable data about the moon. To understand the core question, we first need to look at the Apollo 11 landing site in the Sea of Tranquility. Apollo 11, which successfully landed on the moon in July 1969, left behind the lunar module's descent stage and various scientific equipment. Physical evidence like footprints, the American flag, scientific instruments, and the descent stage are still on the lunar surface, confirmed by other high-resolution orbiters. Let's examine Chandrayaan-2's instruments and what they were designed to achieve in orbit. The Chandrayaan-2 orbiter carries the High-Resolution Camera, or OHRC, capable of producing images with a resolution of 25 centimeters per pixel. While impressive, This resolution means small objects like individual footprints or small gear left by Apollo 11 would be challenging, if not impossible, to distinctly capture. The core question is, did Chandrayaan-2 prioritize or even manage to image the Apollo 11 landing site? Chandrayaan-2's mission focused on lunar composition, mineralogy, and water ice search, primarily targeting the South Polar region, not the Apollo 11 site near the equator. While the orbiter has provided vast images of the moon, there were no official announcements or high-resolution images released by ISRO, specifically confirming detection of the Apollo 11 hardware. So what is the definitive answer regarding Chandrayaan-2 and Apollo 11 evidence? Chandrayaan-2 did not capture or release definitive, high-resolution evidence of the Apollo 11 landing site, as it was not its primary mission objective, nor its targeted region. It's essential to rely on verifiable scientific data and mission objectives when discussing space exploration facts. Other orbiters, like NASA's LRO, have confirmed the Apollo sites. The moon has always fascinated humanity. But what did two major missions, Apollo 11 and Chandrayaan-2, actually find on its surface? We're diving into the groundbreaking discoveries made decades apart by the United States Apollo 11 and India's Chandrayaan-2 missions. Apollo 11 in 1969 achieved the first human landing. Chandrayaan-2, launched in 2019, aimed for a soft landing with an orbiter, lander, and rover component. Their goals and landing sites were vastly different, leading to unique and crucial findings for lunar science. Let's start with Apollo 11, the mission that defined space exploration. Apollo 11 landed in the Sea of Tranquility, a relatively flat equatorial region, prioritizing safety for the first manned landing. The astronauts brought back 21.5 kilograms of lunar surface material, including rocks and soil, known as regolith. Analysis of these precious samples provided definitive evidence on the moon's formation and confirmed its composition, fundamentally changing our understanding of the solar system. Now, turning to Chandrayaan-2, a mission focused on new frontiers and resources. Chandrayaan-2 targeted the largely unexplored lunar South Pole region, though its Vikram lander sadly experienced a hard landing. Despite the lander's fate, the mission's orbiter successfully detected definitive signatures of water ice and hydroxyl, primarily in the permanently shadowed regions. The orbiter also created detailed maps of the distribution of key surface elements like magnesium, calcium, and iron, providing a comprehensive elemental picture of the region. Comparing these missions highlights the evolution of lunar exploration strategies. Apollo relied on physical samples for direct analysis, while Chandrayaan-2 utilized advanced remote sensing to map and analyze the moon's surface from orbit. The discovery of water ice is revolutionary, suggesting potential in-situ resources for future human missions, like propellant or breathable air. Both missions, though different in scope and era, provided invaluable insights. Apollo established the moon's geological timeline through samples, while Chandrayaan-2 revealed the crucial possibility of lunar resources in the cold polar regions. From the first footsteps to resource mapping, these missions paved the way for a sustainable human presence on the moon and deeper space exploration. The discoveries continue.